Buckle up, listeners, because today we're diving deep into our cosmic neighborhood.
Ooh, cosmic neighborhood.
The solar system, we're going from the familiar, like our own pale blue dot, to the alien.
Right, and you sent us tons of info from Wikipedia's solar system entry.
It's a lot, but thankfully we have an expert to to guide us. So before we get into the specifics of every planet,
Sure.
can you give us a sense of the scale? Because when I look up at night, it feels deceptively small.
Yeah, it's a common thing.
Yeah.
We picture the solar system as this neat little mobile with the planets all equal distance, but it's way more mind-boggling than that.
So ditch the mobile analogy.
Okay.
Give me something to really wrap my head around this.
Okay, imagine this. If the sun were the size of a golf ball
Okay.
on the ground,
Okay, picture it.
Earth would be the size of a pinhead, orbiting about a meter away.
Wow. And I thought my apartment felt small. Okay, so where are the other planets in this shrunken solar system then?
Well, to reach Jupiter, the biggest planet, you'd walk 5 meters away from our sun golf ball.
Okay.
And to get to the edge, where Neptune is, you'd be walking like 30 meters away.
Wow, that's way more spread out than I ever pictured.
Yeah.
So all that space in between, it's not empty, right?
No, definitely not. There's way more than just planets in the solar system.
Okay.
We've got dwarf planets, moons, asteroids, comets, tons of smaller bits, all held together by the sun's gravity.
Okay, so how did this stuff even get here? I know there's that whole nebula thing, but how did it actually work?
So yeah, it all started with a nebula, billions of years ago,
Okay.
which is a giant swirling cloud of gas and dust.
Like a cosmic construction site.
Exactly. And it starts to collapse on itself due to its own gravity.
So everything just starts clumping together.
Exactly. And as it clumps, it spins faster and faster.
Okay.
Like an ice skater pulling their arms in.
Okay.
And then this spin causes the cloud to flatten into a disk with most of that material concentrated in the center.
Okay, so I'm picturing this spinning, flattened disk of gas and cosmic dust. Then what happens? How do we go from that to our solar system?
So then it gets really interesting. The central clump, with most of the mass, eventually gets so hot and pressurized that it ignites.
Okay.
Boom, the sun is born.
Talk about a dramatic entrance. So the sun just bursts into existence at the heart of this swirling disk.
Right.
So what happens to all that leftover gas and dust?
Okay, so the planets form a bit later, but the sun's birth is actually crucial to that formation.
Okay.
So as the sun ignites, it unleashes this powerful solar wind,
Okay.
a stream of charged particles that blast outward.
Oh, wow.
And this wind is like a broom, sweeping away the gas and dust.
Cosmic house cleaning.
Exactly. So this is where the frost line comes in.
Okay.
This is a boundary in the early solar system that was super important in shaping the planets we see today.
Oh, okay.
Inside the frost line, closer to the sun,
Yeah.
it's too hot for things like water and methane and ammonia to exist as ice.
Okay.
They remain vapor and were mostly swept away by that solar wind.
So wait, back up. You said the frost line determined the type of planets that formed. How so?
Well, because with those lighter elements gone, the inner region has mostly heavier elements like rock and metal. And those, under their own gravity, start clumping together, forming the inner rocky planets.
Okay.
Mercury, Venus, Earth, and Mars.
So the inner solar system is like the heavy metal fans,
Yeah.
forming those dense rocky planets. What about past the frost line? That's where the gas giants are, right? Like Jupiter.
Right. Outside the frost line, it's a different story.
Okay.
It was cold enough for those lighter elements, the water, methane, ammonia, to freeze into ice particles.
Oh, okay.
And since there was more material out there, those planets could grow much larger, pulling in those ices and tons of hydrogen and helium gas.
So they were like playing King of the Hill, gobbling up everything.
Exactly, and that's why you have Jupiter and Saturn, those massive gas giants, just dominating the outer solar system.
Okay.
In fact, together, they're over 90% of the mass of all the planets.
90%. Wow, that really puts things in perspective. We
Yeah.
think of Earth as this big, important place, but I mean, in our solar system, it's not that big a deal.
It's humbling.
Okay, so let's do a quick tour of the heavyweights. What makes them unique?
Well, starting with Jupiter,
Mm-hmm.
I mean, you can't talk about Jupiter without mentioning the Great Red Spot.
Yeah.
That monstrous storm, bigger than Earth, that's been raging for centuries.
I remember seeing pictures. It's like this giant red hurricane.
Right. Like, it's just, the scale is unbelievable. And
Yeah.
what's fascinating is that it's always changing. Like, in the last century, it's actually shrunk.
Oh, wow.
Some scientists even think it might disappear in the next few decades.
So even these permanent features are changing. That's wild. Okay, what about Saturn? It's always been my favorite because of those rings. They're so delicate, but so big.
Oh, yeah. Saturn's rings are iconic. You can see them from Earth, with a small telescope even. And
Yeah.
they're made of countless icy particles,
Really?
from tiny dust grains to chunks bigger than a house.
Wow. I always pictured them as more solid.
No, no, they're super thin, proportionally thinner than a sheet of paper. You could probably fly a spaceship through and not even notice. And
Wow.
there's this mystery about their age. Saturn formed billions of years ago, but some scientists think those rings are much younger, maybe forming later.
No, that's a twist. Ancient planets, young rings. It makes you wonder what else we've got wrong. Okay, so Jupiter, Saturn, the heavy hitters. What about those icy giants, Uranus and Neptune? They're kind of mysterious, hiding out there in the dark.
They are. Uranus is a weird one, tilted on its side.
Yeah.
Like got knocked over in a cosmic billiards game. And because of that tilt, it has these extreme seasons.
Okay.
Like imagine decades of constant sunlight followed by decades of darkness.
That's a long winter. Anything even live on a planet like that?
That's the thing. Life on Uranus, if it's even there, would have to be insanely adaptable.
True, true. All right, last but not least, Neptune, the farthest planet. What
That's
makes
right.
it stand out?
Well, it's known for that amazing blue color,
Yeah.
which comes from methane in its atmosphere.
Yeah.
But don't let that fool you. It's actually got a really stormy, active atmosphere.
Really?
Yeah, with super fast winds. So even though it's far from the sun, it's got its own internal fire going on.
That's pretty cool. So even though it seems calm and blue, it's not.
Exactly, and that kind of goes for the whole solar system.
Yeah.
Appearances can be deceiving.
Yeah.
Jupiter's storm shrinking,
Hmm.
Saturn's rings, maybe being young. There's always more than meets the eye with these objects.
Okay, so we've explored the sun, the 8 planets, and, things like asteroids.
Right.
But it doesn't end with Neptune, does it? What's out there in those even more distant regions?
That's where things get really interesting.
Okay.
If the inner solar system is like a bustling city center,
Okay.
and the outer planets are like kind of remote outposts, we're talking about like unexplored wilderness now.
Oh, okay. I'm intrigued. Lead the way.
So between Jupiter and Neptune's orbits,
Yeah.
we've got these things called centaurs. They're kind of cosmic hybrids, part asteroid, part icy comet.
Interesting.
And they've got these wild orbits, swinging them around.
Okay.
And they even sometimes act like comets, growing tails when they're near the sun.
So they're having an identity crisis, these centaurs.
Yeah, you could say that. And there's one, Chiron, that's actually classified as both.
Oh, wow.
But the real action's in the trans-Neptunian region. That's where the Kuiper Belt is, home to Pluto and a bunch more dwarf planets.
Ah, the Kuiper Belt, always in the news because of Pluto's demotion.
Right, but Pluto's not alone. The Kuiper Belt's like a cosmic deep freezer
Okay.
full of icy leftovers from when the solar system formed. And it's huge, way past Pluto.
So it's more like a disk of icy stuff, not just a belt.
Yeah, and within that, there's the scattered disk.
Okay.
Objects there have really distant, chaotic orbits scattered by the giant planet's gravity.
Right.
And they're thought to be where a lot of those short period comets come from, the ones that swing by Earth.
So those comets we see every few years, it could be from there.
Likely. And if you thought that was far out,
Yeah.
there's even more extreme objects with crazy orbits.
Like what? Give me the good stuff.
Okay, how about Sedna? One of the most distant things we've seen in our solar system.
Okay.
Its orbit takes over 11,000 years.
11,000 years. It's barely even connected to us at that point.
It really makes you think about what solar system even means.
Yeah, no kidding. And that's still stuff orbiting the sun, right?
Right, but the sun's influence goes even further as the heliosphere.
Okay, the heliosphere. Not familiar with that one.
It's this giant bubble blown out by the solar wind protecting our solar system.
Oh, interesting.
Like a force field, shielding us from interstellar radiation. And its edge, where it meets interstellar space, that's the heliopause, the very edge of the sun's influence.
So the sun has its limits. What's beyond that, though? Is that where it truly ends?
It's more of a transition. Way out there, further than we've seen, is the Oort cloud,
Okay.
a vast cloud of icy bodies, thought to be where the long period comets come from, the ones with orbits lasting hundreds, thousands of years.
Wow. So a reservoir of icy wanderers. Where'd they even come from in the first place?
That's one of the mysteries. Likely, they formed closer to the sun, then got flung out by the gravity of those giant planets we talked about.
This whole journey has been incredible. Started with planets we kind of know, and here we are in the realm of cosmic mysteries.
And we've only scratched the surface. Our cosmic neighborhood is vast, with who knows what waiting to be discovered.
This has been an amazing deep dive into the solar system, from the familiar to the truly mind-boggling. Until next time, keep looking up, listeners. Who knows what you might find?